Now, our last topic in Chapter 8 is Section 8.4, which is on concentration. Concentration is how much solute is dissolved in a solution. We have a couple different ways that we can express this, right? Some of the simplest is we look at percent concentrations. Now, I want you to pay careful attention here because I will ask you about this and students will always get this wrong. So I want you to pay careful attention to what I'm saying. Percent concentrations, basically to calculate them in general, we're going to talk about a couple of specifics, but it's going to be amount of solute per amount of solution times 100%. Now, the key in this, amount of solution. Okay. Now, let's look at calculating, just for example, percent mass over mass. Okay. We can use any units for mass just as long as we're using the same thing on the top and on the bottom. But let's say that I dissolve, I mentioned this earlier, but let's say that I have 5 grams NaCl in 100 milliliters of water, right? So, what are we going to do? To calculate this, we're going to calculate 5 grams of NaCl, that's our solvent. Now, a lot of you will probably be tempted to say, I'm going to rewrite this because we know that the density of water is close enough to 1 gram per milliliter. I'm going to say 100 grams of water. Please forgive me for that. But anyway, a lot of you are going to be tempted to write 100 grams of water down here. And that's a reasonable thing to think, but it's completely incorrect because note again that we said amount of solution. Okay? We've dissolved the sodium chloride in our water. That means that both the sodium chloride and the water are now contributing to the mass of the solution. Right? So what's our mass of solution? It is now 105 grams. So we do this. And we find that it is 4.8%. Now, I say that when I teach this class in person, I stand up and I talk about this until I'm blue in the face, and I always have people get it wrong. So please don't be that person who gets this wrong, all right? Now, let's look at something else, or let's look at another type of percent concentration. Let's do percent volume per volume, right? Same deal. We can work with anything as long as we have the same units on top and on the bottom. But it's going to be volume of solute over volume of solution. Now, for any problem that I am going to give you for this, we have to make a fundamental assumption that volumes are directly additive. And I will specify that assumption. I'll specify that assumption in the problem. I always will specify that assumption. But now I say that is not actually correct for a lot of solutions. But in order to work the problems in here with the level of knowledge we have, and really honestly with the level of knowledge that we have in any class short of like a PChem class, the only way we can work these problems without doing it experimentally is to make this assumption. Okay, so let's say hypothetically that I dissolve 10 milliliters of ethanol in 60 milliliters of water. Now, there again, volumes are not directly additive for this in the real world, but we are going to assume that they are. So that means that we are going to, if we add these two together, we're really probably going to get about 58 milliliters. There again, we're going to ignore that. I mentioned that though because that's actually something I know a lot of people will have talked about in a previous chemistry class. Okay? But we're going to treat this as if we have 70 milliliters of solution, right? 10 milliliters divided by 70 milliliters times 100%. Again, though, volume of solution, not volume of solvent. And we get 14.2%. All right. Now we can also do percent mass over volume. So let's say hypothetically I dissolve 2.2 grams of glucose in 330 milliliters of water. Now, I am going to go ahead and tell you this is not strictly 100% true, but for anything we do in here, we need grams for our mass and we need milliliters for our volume. Okay. Now, what effect does dissolving this have on the volume? Well, truth be told, so dissolving a solute in a solvent does affect the volume, but we can't predict how much that is. And so my real solution to that is that I am going to give you problems where the amount of volume is going to be insignificant, or I will phrase it as 2.2 grams of glucose dissolved in water to a volume of 330 milliliters. And actually in the lab, that's how we tend to make solutions. Okay, we'll dissolve some of our solute in our solvent, and then we will further dilute it until we get to our actual desired volume. Right, so 2.2 grams over 300 times 100%. And we get 0.67%. All right. So that's how we do percent mass over mass. Now, let's look at a couple of related problems, or a couple of related units, the ppm and the ppb. ppm is parts per million. ppb is parts per billion. Okay. Now, to calculate ppms, ppms are milligrams per milliliter. ppbs are micrograms per milliliter. Note that these are not times 100%. Okay. Now, let's go ahead then to what I consider our most chemically useful one, just because it allows us to, or at least for chemists working in the lab, this is what I would consider our most useful one, and that is molarity. Molarity is moles of solute per liters of solution. Now, this tends to be a little bit more involved to calculate, because let's say that we dissolve 16.2 grams of sodium hydroxide to a TV total volume of 503 milliliters, which is going to be 0.503 liters. We're going to say this is in water, even though really it wouldn't make a huge difference if it was in a different solvent, other than that water is what sodium hydroxide is most soluble in. But anyway, okay, what do we do with this? We have grams. We need moles. So how do we go from grams to mole? We need our molecular weight. Okay, Na 22.99, that's from the periodic table. O is 16.00, H is 1.01. Add these up, we should get 40.00. Now, that's grams per mole, so if I take 16.2 grams, I'm going to multiply it by 1 mole over 40.00 grams, and I am going to get and that is going to be 0.405 moles. Then I can do 0.405 divided by 0.503 liters. And I get 0.81. I'm sorry, I should be within sig figs, 0.805 moles per liter, or we abbreviate that with a capital M. All right. So that's how we calculate concentrations.